and the layers are loosely bounded because it has OO bond. So the water cations can enter inside. So the expansion is high. Therefore, high plasticity and stickiness is present. And here the internal surface can area expands the external surface, exceeds the external surface area, and isomorph substitution is high. Next one, absorption of water. In this, there's more absorption of water. So during the wet period, it will swell, and during the dry period, it will shrink. And during the dry period, there will be white cracks.
Hayavarna?
Yes, ma'am. Yes, madam.
What about 2:1 limited extent?
It contains two silicon tetrahedral layers, one aluminium octahedral layer. The octahedral sheet is dominated aluminium. Sometimes magnesium is dominated. Magnesium ion in the water molecules are strongly absorbed in the layer. The high negative charge silicate clay is contained.
So, which chemical property is most important for soil fertility?
Kaolin.
No, I'm asking which chemical property?
Soil colloid.
Soil colloid is a kind of part or composition of soil. No? I'm asking about the properties.
Cation exchange capacity.
Okay, so and why cation exchange capacity is important for soil fertility?
Absorb the nutrients, collagen nutrition.
Okay. If the cation exchange capacity is high, it will exchange the nutrient more compared to low cation exchange capacity soil. Okay. So the nutrient use efficiency or nutrient application efficiency is higher in high cation exchange capacity soil. If you apply, for an example, if you apply a 10 kilogram of urea to high cation exchange capacity soil and low cation exchange capacity soil, the efficiency is more in high cation exchange capacity. It will exchange more amount of nutrient in with surface. In low cation exchange capacity, leaching is high, so the fertilizer loss is high. Waste economical loss also occur. Okay. And what is soil colloids? What is soil colloids?
Soil colloids are the particles with diameter of less than 0.0
I couldn't hear your voice properly. Anyone to?
The mineral section of the soil determines most of the saturating properties of soil greater than 0.001 millimeter.
So, can anyone list out the properties of soil colloids?
size, surface, surface charge.
Okay, so what about size? Explain each property.
Their size is less than 1 micrometer or less than 0.001 millimeter diameter. They can only observe by electron microscope.
Okay. Surface area. Any other? Mayuri Disanayaka.
Yes, ma'am. Small surface area, small size all collides expose a large amount of external surface. External surface area of 1 gram of soil collides or is all said. The internal surface area commonly exceeded the external surface.
So you can expect this question, okay? Which one? Soil colloids or sand have more surface area? Likewise, you can expect the question. And don't confuse with size and surface area. Small size have large amount of external surface area than large size particle. Remember this one also. You can observe net negative charge around the soil colloid. If the amount of charge is high, the cation exchange capacity ability also high. How can you classify the soil colloids? This question also you can expect for your mid-examination or final examination. Classify the soil colloids and give one examples for each type. Okay. So who is going to answer this question?
Can classify animal.
Okay.
Can classify organic, inorganic. Further inorganic classified layers in place, iron and aluminum hydroxide, allophone and other amorphous minerals. Layers with place further can do it 1:1 type, 2:1 type, 3:1 type.
You can classify, majorly you can classify colloids into organic and inorganic. So you have to be in a position to compare organic colloids as well as inorganic colloids. You can expect that question also. And again, you can classify the inorganic colloids into 3 major groups: layer silicates, iron and aluminium hydroxide, allophane and other amorphous minerals. And again, you can subdivide the layer silicate into 1:1 type, 2:1 type, 2:1 type. And 1:1 type means you can observe one aluminium octahedral and one silicon tetrahedral. In between layers, you can observe hydrogen bond. It means strong bond. So the example is kaolinite, and this one is suitable for construction purpose because the swelling ability is very much low, so it's more suitable for construction purpose and road construction purpose. So this information is enough for 1:1. Example is kaolinite. In between the layers, you can observe very strong hydrogen bond. So no internal surface area. So the external surface area is only available here. 2:1 type, again you can classify into expanding, limited expanding and non-expanding. Here two aluminium, silicon tetrahedral and aluminium octahedral you can observe one aluminium, and in expanding type weak oxygen bond. So water molecules can enter in between the layers. So it has internal surface area as well as external surface area. What's the example for expanding?
Smectite.
Smectite. And limited expanding means here also the bond between two molecules are weak, and here you can the magnesium is dominated the aluminium, so you can observe more negative charges. So due to more negative charges, the cation exchange capacity is higher than SMEC type, higher than expanding type. And in non-expanding type, in between the layers, the K plus ions are fixed. So the K plus ions are more suitable when it's in suitable size to fix in between the layers. So it also doesn't have internal surface area compared to expanding and limited expanding. And what's the example for non-expanding type?
Vermiculites.
Okay. Sorry, non-expanding.
We want to study non-expanding type.
So you didn't read the slides, no? Vermiculites example for limited expanding.
Yes,
And non-expanding, fine grain mica. And 2:1:1 type, we will study. Now we are going to study. Is it visible?
Yes.
Yes, ma'am.
So Aaron, can you start? Aaron?
Yes, ma'am.
Okay. 2:1 non-expanding type.
So the 2:1 non-expanding type have silica tetrahedral layer and two silica tetrahedral layers and one octahedral layer. Whether the mineral similar in structure to muscovite and biotite mica are found in clay fraction of soil called as the fine grain mica. The particle size is larger than the semectite, a major source of charge in tetrahedral sheet because here 20% of silicon are substituted by aluminium cations, which leads to high net negative charge. To satisfy this charge, K plus are strongly attached in the interlayer space. So the potassium K plus has a right size to be fit into the space in adjoining tetrahedral sheet. K plus act as a binding agent and prevent expansion of the crystals. So these are non-expanding type.
Okay. Here also you can observe two silicon tetrahedral layer and one octahedral layer. Okay, here the particle size is larger than SMEC type. SMEC type means 2:1 expanding type. Here particle size higher means surface area is lower than SMEC type. And 20% of the silicon are substituted by aluminium cations, which leads higher net negative charges, and these negative charges will attract K plus ions strongly, and these K plus ions are right size to be fit into the space. Okay, so it ultimately leads to non-expanding nature. Aaron?
Therefore, hydration, cation absorption, swelling, shrinkage, and plasticity are less than smectides. These mica smectides These micas exceed kyolinite with respect to these characters. Crystal size is kyolinite is greater than mica. Mica is greater than the smectite. Smectite.
Then who is going to do this slide? Okay. So please try to remember the classification and one example for each type. Okay, don't forget that one. And you can expect this question also. Compare and contrast or differentiate 2:1 expanding and 2:1 non-expanding type clay. Who is going to answer this question? Compare and contrast 2:1 expanding type and 2:1 non-expanding type colloids. Compare and contrast means you have to give the similar nature as well as different nature. If the question is differentiate 2:1 expanding and non-expanding means just write the differences enough. If the question is compare and contrast, first you have to write the similarities, then differentiation. Okay. Each colloids have two silicon tetrahedral and one aluminium octahedral. Similarity. And again, you can give one example. Second point. Third point, differentiation. Can anyone answer? No one is ready. Sadanika 121.
Just now.
What's your answer for this question? Jolene Nivashana Anthony.
Yes, ma'am.
What's your answer? Compare and contrast 2:1 expanding type colloids and 2:1 non-expanding type.
Both have two silicon tetrahedral layer and one aluminium octahedral layer.
Hmm?
Both particle size is larger than smectite.
Hmm? What's the difference? Any others? Sindhuja? Yes, ma'am. Answer. What about your answer? Kayavarna? Kayavana.
Yes, ma'am. Both type magnesium is dominate the octahedral shape.
Two is to one, expanding and non-expanding. Arani?
Yes, ma'am.
Okay, next class, I will ask the same question, okay? Compare and contrast. 2:1 expanding colloids and 2:1 non-expanding colloids. Surely you will expect, you can expect this question for your mid exam. Then next slide. Ashika Ramachandra. Zero zero 007.
Yes, ma'am.
007, are you there?
Yes, ma'am.
Just read the slide and then explain it. Hanshika Sandamini 052. Can you do it? Hanshika. One zero nine. Dharmika Selvarasa.
Yes, ma'am.
Hanshika today absent, no? Dharmika. Your turn to explain. Dharmika, is there?
Yes, ma'am.
Do you have any problem?
Fever, ma'am.
Okay. Prapurna Sivasudan. Prapurna 165. One six five also absent.
Yes, madam.
Prapurna.
Yes, madam.
Okay, okay. Continue.
Iron and aluminium hydroxide hydrous oxide clays modified
Prapurna.
Miss, shall I read?
yes, it's difficult, madam. Sorry.
Okay, then who is going to do?
Shall I read?
Okay.
Iron and aluminium hydroxide clays modify of octahedral sheet with either Fe2 plus or aluminium 3 plus in the cation position. They have neither tetrahedral sheet or silica in their structure. Example gypsite AlOH thrice. This is a prominent constituent of the highly weathered soil. Other examples are goethite, ferric hydrate, Fe2O3.NH2O found in temperate region and yellow in color. Hematite Fe2O3 found in dry environment and red in color.
So here you can observe modified octahedral sheet with iron or aluminium. And the example, try to remember 2 examples. Okay, that's enough. Continue. We are set.
Properties. Most are atmospheres and some are crystals.
Amorphous means
Amorphous.
doesn't have shape. Okay.
Okay. Little or non-isomerous substitution and don't have much negative charge. Additional or removal of hydrogen ions cause net charges. Non-expanding, little thickness, less plasticity, and less cation absorption. And therefore, this clay can be cultivated immediately after rain. Small aggregations occurs, hence promote structure formation and flow calculation.
So the properties are here: no little isomorphous substitution, and don't have much negative charge. The charges will create due to addition or removal of hydrogen ions. Okay, most are amorphous. Amorphous means doesn't have shape. Okay, fixed shape. Some are crystals. Okay, and try to remember 2 examples. The next major category is amorphous silicate clays. Who is going to explain this one? Okay. Here also amorphous silicate clays doesn't have shape. By the name itself, you can understand. Amorphous means doesn't have shape, non-crystalline, and example. That one is enough. Other things just read for your knowledge. Organic colors are the important criteria. Okay? Inorganic and organic, the comparison between inorganic and organic colors are very much important. Nusrat Banu 032.
Yes, ma'am.
Can you do it?
Okay. Organic colloids. Example is humus. It is formed from breakdown and alteration of organic residues by microorganisms and synthesis of new more stable organic compounds. Complex structures are not well known about its structure, and the carboxylic, phenolic, and enolic groups are major sources of negative charges. Under strongly alkaline condition, hydrogen from these groups could be replaced by other cation. These negative charges are pH dependent. Under strongly acidic conditions, the hydrogen ions are tightly bound and they cannot be easily replaced by other cations. Therefore, cation exchange capacity is low.
So this slide is very much important. Okay, comparison between organic and inorganic. Inorganic formed due to weathering of rocks and minerals, and organic due to decomposition of organic materials. And organic colloids, most of the charges are pH dependent, and in inorganic, only some charges are pH dependent. And inorganic colloids have shape, fixed shape, crystalline in nature, and organic colloids doesn't have shape. All are amorphous in nature. Organic contain carbon, hydrogen, and oxygen. In inorganic colloids, aluminium, silicon, magnesium, oxygen, and iron. If we compare the cation exchange capacity, organic colloids have more cation exchange capacity, and inorganic colloids have low cation exchange capacity compared to organic. Okay, that's why to improve a soil fertility, addition of organic matter is a good management practice. If we add more organic matter into the soil, it will increase the cation exchange capacity, and it will increase the nutrient retention and nutrient exchange ability, and ultimately it leads the soil into fertile condition. Okay. This slide is very much important, so try to understand and then try to remember also. A simple comparison between layer silicates. Kyalulinite 1:1 non-expanding, no swelling in between two layers. You can observe hydrogen bond, and in expanding type, again you can classify into three. In 2:1 type, you can again classify into expanding, limited expanding, and non-expanding. Expanding example, smectite. In between smectites, weak bond. So you can observe internal as well as external surface area. For 2:1 limited expanding, example vermiculites. In between two layers, you can observe weak bond, and here due to magnesium ion dominant nature, you can observe more negative charges. So the cation exchange capacity is high, and not in 2:1 non-expanding type. The example is fine grain mica. You can observe K+ ions in between the layers, so it doesn't have expanding nature due to that K+ ion present. And the last one, 2:1, 2:1 type. And, example is chloride. Okay. And this slide, no need to remember the values. Just remember the comparison. Which one is higher than which one, or which one is lower than which one. That one is needed, but no need to remember the values, exact values. Okay. Humus means organic colloids. Okay, last column organic colloids and others inorganic colloids. Next class you all have to answer that question. Okay, the comparison between 2:1. With the help of this chart, you can write the answer. Comparison between 2:1 expanding and 2:1 non-expanding.
Okay, ma'am.
Thank you.
Thank you, ma'am.
Thank you.